Hello everyone, I'm Manuel Caccone and I want to start with a conversation I had just 3 months ago with a mid-sized regional insurer's chief actuary. She told me, Manuel, we know AI could transform our work, but we see what the big players are doing. But when I look at the price tags, $10,000, $15,000, $20,000 a month, I have to tell to my team that it's not for us. We cannot afford it. How many of you have heard something similar? And how many of you have said something similar? This is the conversation happening across our industry right now. Not in the Fortune 100 insurers, but their massive technology budget, but in the mid-market companies, the regional players, the specialized insurers organization that represent the majority of our profession. And here's what bothers me most. That Chief Actuary wasn't wrong about the costs. Traditional AI platforms do require those kind of investments. But she was wrong about something else. She was wrong that advanced actuarial AI isn't for her team. So today I'm going to show you a different path. A path where a sophisticated production-grade AI platform for actuarial work costs 95% less than traditional solution, where vendor lock-in is eliminated entirely, where your code, your models, and your infrastructure belong to you and travel with you wherever you go. But this is just about the cost. It's about democratizing actuarial expertise itself, making sophisticated analysis accessible not just to organizations with deep pockets, but to teams of all sizes. And it's about transforming how actuaries works, shifting us from report writers to strategic thinkers. Let me show you how we've built this. So we have the cost barrier problem. Let's be honest about the economics. Traditional machine learning platforms for insurance typically run $10,000 to $20,000 per month in infrastructure costs alone. Look at this chart. That's before you add the data science team, before you hire the machine learning engineers, and before you factor in the 6 months implementation timeline. For a mid-market insurer, that's a budget line that competes with hiring 2 actuaries. And when you present that business case to your CFO, what happens? The AI initiative gets delayed again. But the cost problem is only half the story. The other half is the vendor lock-in. And when you build on one platform, you're committed to that vendor. Your models are tied to their infrastructure, so your workflows depend on their APIs. Your team learns their specific tools. And if that vendor raises the price 40%, if they get acquired and the new owner changes the terms, and if their technology stack falls behind, you're stuck. Because switching vendors means rebuilding everything from scratch. This creates what I call the economic barrier, a threshold below which entire segments of your industry simply cannot access modern AI capabilities. Not because they lack the skill, not because they lack the vision, but because they lack the budget. And that's not acceptable. Because the actuarial profession shouldn't be divided into the haves and have-nots based on the organization size. So here's what we built, a tree-model architecture that works together in a sophisticated pipeline. Each model has a specific responsibility and together they transform a business question in a complete actionable analysis. Think of it like a relay race where each runner has a specialized skill. Let me walk you through it. The simplifier comes first. When someone asks, what's our exposure for coastal properties, for example? That's a business question, not a technical specification. The simplifier is a fine-tuned Llama 3.18 billion model optimized purely for reasoning. Its job is to translate that business question in a complete actuarial chain of thoughts. It says this is an exposure analysis question. I need to identify geographic risk zones, aggregated insured values by coastal proximity, consider storm surge models, evaluate concentration risk, and calculate probable maximum loss scenarios. Notice what is just happened. We went from a 5-word question to a complete analytical framework. That chain of thoughts is gold. It's the reasoning process that an experienced actuary would follow. This slide highlights how actuarial reasoning can be expressed consistently across multiple languages, ensuring accessibility for professionals worldwide. By leveraging open source material and recognized actuarial foundation material, the multilingual approach maintains both credibility and technical accuracy. The coverage of 8 key languages means that more than 90% of actuarial professionals can work in their native language without losing conceptual rigor. Overall, the slide emphasizes that linguistic diversity is a strength, not a barrier, for modern actuarial science and data-driven decision-making. Then, returning to our architecture, then the chain of thoughts flows to two models simultaneously, the reporter and the excelifier. Both are based on Quen 2.5 14 billions of parameters, but they're fine-tuned for completely different outputs. The reporter generates production-ready RMarkdown code. It creates professional reports with proper statistical analysis, clear documentation, and actuarial best practice baked in. When it runs, you get an HTML report that you could hand to a regulator. The excelifier generates R code specifically designed to produce Excel workbooks, not just data dumps, interactive workbooks with embedded formulas and multiple sheets and visualization and assumption documentation, the kind of Excel file that business stakeholders can actually use and modify. Same analysis, same underlying chain of thoughts, but two different deliverables optimized for two different audiences. Technical reports for actuaries and regulators, interactive workbooks for business users. Now, why this architecture? Why not just one massive general purpose model? Because specialization matters. The simplifier is more than 10 times smaller than a general purpose LLM. But it's better at actuarial reasoning because that's all it does. And the reporter and the excelifier are fine-tuned specifically for code generation in our domain. This is like having 3 specialists in our team instead of one generalist trying to do everything. And it's far from cost effective to run. 2. Lower memory usage. Training happens on a consumer-grade hardware. I trained early version of these adapters on a system with 96 gigabyte of virtual RAM of GPU. Powerful, yes, but not the massive compute cluster that full model training requires. So number 3, easier integration. Lower adapters work seamlessly with Hugging Face transformers and other popular frameworks. This means our open source community can easily modify and extend them. Number 4, cost effectiveness. Because training is faster and requires less hardware, the cost barrier to experimentation drops dramatically. When someone in our community wants to create a lore adapter for a pension calculation or reinsurance analysis, they can actually do it. This architecture choice, specialized smaller model with lore adapters, is what makes the economics work. We are not trying to compete with GPT-4 or Cloud Opus on general knowledge. We are building models that are better than those general purpose giants at actuarial reasoning, precisely because they're specialized. Now here's the thing about code generation models. They make mistakes. Every model does. They hallucinate, they generate code with syntax errors. They call functions that don't exist. They forget to load the required libraries sometimes. In research environment, that's fine, you just fix it manually. But in production, when a business analyst is trying to get an exposure report at 4 p.m. for a 5 p.m. meeting, unacceptable. So we built what I call the Agentic framework, a quality assurance engine that never sleeps. It's built in Cloud Code, and it transforms this platform from interesting research to a production-grade system. Here's how it works. When the reporter on the excelifier generates code, that code doesn't go directly to the user. It flows into an execution environment where the agentic framework analyzes it. And if the code runs perfectly, great, the user gets the report. And if the code has errors, the framework captures those errors, analyzes them, fixes them, and re-executes automatically without human intervention. Let me give you a concrete example. The reporter generates code that calls a function from the chain ladder package, for example, but forgets to load the library. The code fails, the agentic framework sees the error message couldn't find function chain ladder. It recognizes this as a missing library error. It modifies the code to add the library chain ladder at the top, and re-execution will work, and the code works. Total time, seconds. User impact, 0. They just get a working report. Or consider a more subtle case. The excelifier generates code that tries to write a sheet name that is too long for Excel's limits. The code fails. The framework truncates the sheet's name and adjusts all the references to that sheet, and re-execution will work. Again, the user sees none of this. They just get a working Excel file. This is a production reliability without requiring perfect model outputs, because here's the reality: we're never going to get the models that generate perfect code and 100% of the time, but we can build systems that catch and correct errors automatically. The agentic framework eliminates hallucination that would otherwise require human intervention. It catches error you should never see coming, and it provides production reliability with zero manual intervention. This is what makes the platform actually usable in a real actuarial workflows, not just impressive in demos. Now let's talk about how we achieve that 90% cost reduction I mentioned at the start, because it's not magic, it's architecture. So traditional machine learning platforms require you to rent a server instance 24 hours 7/7. That server sits there running, consuming electricity, accumulating charges whether you're using it or not. You pay for the infrastructure during the business hours. You pay for it overnight. You pay for it on weekends. You pay for it during holidays. And it's like renting a car for an entire year when you actually only need it for the occasional trips. We built this on serverless infrastructure instead. Specifically, we use containers that spin up when you need them and automatically scale to 0 after 15 minutes of an activity. Look at this cost comparison. Traditional machine learning infrastructure, they cost $2,800 per month. Our serverless solution just $100 per month, and for a mid-market insurance running typically analysis volumes, and that's the 90% savings. But here's what really matters about serverless. It changed the usage economics. In a traditional setup, there is organizational pressure to maximize usage of that expensive 24/7/7 infrastructure. We're paying for it, we might as well as we use it constantly. With this kind serverless, you pay only for actual computational time. Run an analysis that takes 30 seconds, you pay for 30 seconds. Don't run any analysis for 3 days, you pay nothing. And this creates completely different economics for the experimentation and learning. Junior actuaries can explore what-if scenarios without worrying they're wasting an expensive infrastructure time. Business analysts can run quick checks without requesting permission from IT. And from a technical architecture perspective, there is an additional benefit: complete portability, because we're using standard Docker containers running on Ubuntu or other Linux system, and this system can deploy anywhere. Amazon, yes. Google Cloud, yes. Azure, yes. Your own on-premise service, yes. You can even run it on a powerful laptop for testing. Compare that to traditional machine learning platforms when you rent an entire instance 24 7 by 7, pay whether you use or not, logged into a specific vendor's infrastructure. The serverless approach isn't just cheaper, it's fundamentally more aligned with our actuarial work actually happens. We don't need continuous compute, we need burst compute on demand, and that's exactly what serverless provides. So let me walk you through what this actually looks like for an end user, because the technical architecture only matters if the user experience is seamless. An analyst opens the web interface. They type a natural language question: what's our reserve adequacy for workers' compensation in California? That's it. That's the entire user input. 30 seconds later, typically under 30 seconds, they receive two files: an HTML report with complete chain of thoughts, statistical analysis, and professional documentation, and an Excel workbook with interactive calculation they can explore. No coding, no data preparation requirements, no specification documents, no back and forth with the actuarial team, just the question and deliverables. Now, what's happening in those 30 seconds? The simplifier is translating the question in actuarial reasoning. The reporter and excelifier are generating code in parallel. The Agentic framework is validating and correcting that code. The execution environment is running the analysis, and the outputs are being formatted. All that complexity is completely hidden from the user. They experience it as ask the question, get results. This is what democratization looks like in practice. Not just making advanced tools available, but making them accessible, usable by people who aren't programmers, who aren't data scientists, who are just actuaries and analysts trying to get their work done. So in this slide, introduces the simplifier as a fine-tuned reasoning engine built on thousands of actuarial problem sequences and literature pages. It shows how the model takes a high-level business question and systematically transforms it into a structured actuarial chain of thoughts. By acting as a translator between the business and the actuarial domains, the simplifier ensures that complex pricing logic remains transparent and explainable. The motor policy pricing example clearly illustrates how the tool breaks a vague question into a concrete analytical step from data analysis and to pure premium curves. In this slide, we present the reporter as the component that turns actuarial chain of thoughts into production-ready RMarkdown code. It emphasizes that the reporter generates syntactically correct scripts with comments, error handlings, and clear documentation aligned with our best practices. And thanks to its specialized actuarial training, the reporter produces insurance-specific analysis code with embedded narrative explanation. And the example on the right shows how a complete professional HTML report can be produced automatically from the simplifier structured reasoning. And this slide, we can see that is introduced the excelifier as the component that turns chain of thoughts into professional interactive Excel workbooks. And it focuses on non-technical stakeholders by generating Excel outputs that can easily read, manipulate, and use to test different assumptions. The excelifier creates well-organized workbooks with multiple sheets, embedded formulas, visualization, and dedicated assumption documentation. In practice, it ensures that the same robust actuarial analysis available in RMarkdown is also delivered in a familiar Excel format. The system can intelligently choose which model to use based on the task. And because OpenRouter provides competitive pricing across dozens of providers, you're never locked into one vendor's pricing. If Anthropic raises their prices, the system can automatically shift more tasks to OpenAI or open source alternatives. If a new, more cost-effective model emerges, it's immediately available through OpenRouter without any code change. This is what true vendors independence looks like. You're not dependent on any single AI provider. You have flexibility to optimize for cost, quality, or latency based on each specific task. And from an organizational perspective, this provides predictability. Your LLM costs scale linearly with usage. You can budget accurately because you understand the per analysis cost. You can set cost controls that automatically route the cheaper models when approaching budget limits. Compare that to the traditional platforms where you're committed to a single vendor's pricing structure with no ability to arbitrage across providers. We package the entire platform as Docker containers. If you're not familiar with Docker, think of it as a complete self-contained package that includes the application, all its dependencies, the runtime environment, everything needed to run the platform exactly as designed. This provides several critical benefits. First, complete platform encapsulation. You pull the Docker image and set a few environment variables and you have a working system. No complex installation procedures, no dependency conflicts, no it works on my machine but not on yours problems. And second, version control for infrastructure. You can run version 1.2 in production while testing version 1.3 in a staging environments. And you can roll back to an early version if something goes wrong. You have complete control over how you upgrade. And third, reproducible environments. Your test environment, staging environment, and production environment are identical because they're all running on the same Docker image. But here's the most important benefit: true portability with no vendor lock-in. Want to deploy on AWS? Run the container there. Want to move to Google Cloud? Same container. Want to bring it on-premise to your own servers? Same container. Want to switch cloud providers next year? Move to the same container. And your code traveled with you. Your models traveled with you. Your entire platform travels with you. And because this is open source, you can fork the code, modify it, and for your specific needs, integrate it with your internal system, build industry-specific variants, and whatever you need. One life insurance company forked our code to add specialized mortality model and modeling, and they contributed those improvements back to the community, and now everyone benefits. And that's the power of the open source collaboration. You're not dependent on vendors' roadmap. You're not waiting for them to add the feature you need. You have the code, you can modify it, and you can extend it. You own your own future. But the real transformation isn't about the speed, it's about capacity. This pricing team went from completing 4-5 analyses per month to 20 30 analyses per month. That's a 5 times increase in analytical capacity with the same size team. And think about what that enables. Pricing becomes dynamic instead of static. The team can respond to competitive moves in hours instead of weeks, and they can test pricing scenarios that were previously too time consuming to explore. They can segment their book more finely because the analytical cost of each additional segment analysis is essentially zero. And here's what I find most exciting. The actuaries on this team didn't become less important, they become more important. Instead of spending their time executing routine pricing analysis, they're now spending their time on validation, strategy, and judgment calls. They're reviewing the 20-30 analysis each month and identifying the most promising strategies and advising on implementation. They shifted from the execution to strategy, from doing the work to governing and guiding the work. And that's the future of our profession. The second case study involves reserve adequacy testing. This organization needed quarterly reserve testing for 5 different lines of business: personal auto, homeowners, workers' compensation, commercial auto, and general liability. Before our platform, this process consumed 40% of their actuarial team's capacity each quarter. And think about it, and 40% of their time going to a process that happens 4 times a year. The traditional process involved 20 hours of work per quarter: data extraction, model fitting, triangle development, and reserve calculation, documentation, management review, regulatory filing preparation. 20 hours per line across 5 lines, divided among the team. And with our platform, each analysis takes 30 seconds. The total time spent on reserve adequacy dropped from 20 hours to 3 hours per quarter, and 85% reduction. Here's what's even more valuable: the analysis is actually more thorough than before. And with the manual process, there was always pressure to cut corners. Maybe you wouldn't test as many development patterns, and maybe you should skip a certain sensitivity analysis. Maybe the documentation would be rushed because you were up against a deadline. So we have the deployment process begins with account creation on your chosen cloud provider, followed by pulling the Docker image from an open source repository to ensure you have the latest containerized version. And environment configuration is the part 2. And before deployment, you must set environment variables including the OpenRouter API key, cost preference settings, and cloud configuration parameters to properly initialize the system. And daily operation is the number 3. During the daily operation, user submits analysis through the web interface while the system implements automatic scaling that reduces to 0 after 15 minutes of an activity to optimize the cost. And the fourth is the infrastructure efficiency, and the infrastructure features a smart scaling mechanism that transitions from running to idle state and ultimately scales to 0 when no requests are received, ensuring you only pay for the execution time actually used. So we have the open source model that brings together a global community of contributors, including users and auditors, who collaborate around the central project to share knowledge and improve the solution collectively. And transparency and security is another feature. Public code review ensures that anyone can audit the code for vulnerabilities and eliminate the risk of hidden security threats that in proprietary black boxes, and building trust the complete transparency. The vendor independence. Open source solutions are not locked into any single vendor, providing users with complete control over their deployment and the flexibility that do migrate across different cloud providers without restrictions. And regulatory excellence is for insurance and regulated industries. Open source enables transparent processes, complete audit trails for regulators, and explainable AI and system that facilitate compliance reviews and regulatory approvals. So we have an implementation roadmap. So let's talk about practical implementation, because I know some of you are thinking this sounds great, but how do I actually deploy this in my organization? We have deployed a 4-phase roadmap based on real-world implementation. Phase 1 is foundation, weeks 1 till the 4th, and deployed platform on test infrastructure, set up your API keys and cost controls, identify initial analysis to pilot, and this phase is about getting the technical foundation in place without disrupting current operations. Phase 2 is piloting, and weeks 5 till the 10th, and run the platform in a parallel with your traditional processes, compare outputs carefully, document any discrepancies, refine parameters based on your specific data and business context, and this parallel operation builds confidence while managing risk. And phase 3 is validation, weeks 11 till 14. Identify edge cases where the platform struggles, develop internal standards for outputs validation, build governance policies and validation playbooks. This is where you formalize how the platform fits in your control environment. And phase 4 is a scale, month 5 and beyond, and expand to additional analysis, integrate into formal workflows, train broader user population, measure and communicate benefits. Now here are the critical success factors we observed. And first, the executive sponsorship is essential. This isn't just an IT project, this is a transformation in how actuarial work gets done, and you need leadership support. Second, actuary should shape how the system is used. They're not being replaced, they're being elevated to a governance and strategy roles. Make that clear and give it them ownership. And third, expect the first implementation to take longer than subsequent ones, and you're learning, the team is learning, you're building institutional knowledge. And fourth, celebrate early wins publicly. And when you complete that first analysis in 30 seconds that used to take 3 days, tell the people, build the momentum. So let me paint a picture of what the future looks like when this transformation is complete. Actuaries are no longer spending their time writing reports. They're not calculating research manually, and they're not copying data between systems. They're not reformatting Excel workbooks for the 5th time this week. And instead, they're thinking strategically. And they're asking questions like, which assumptions are most uncertain? And where should we focus our validation efforts? And what scenarios have we considered? Where should we focus risk management and attention? And they're reviewing 30 analyses in the time that's used to take a complete tree, and which means they can identify patterns and outliers that would have been invisible before. And they have complete audit trails for every analysis, transparent steps, documented assumptions, reproducible results. Where the regulator asks, how did you calculate this reserve? You can show them not just the result, but the entire chain of reasoning. Stakeholders across the organization have access to a sophisticated analysis. Product managers can explore pricing scenarios, underwriters can analyze risk segments, and CFOs can test capital allocation strategy, for example. And all of them working with actuarial grade analysis, all of them getting results instantly. And the organization becomes more agile. Where market conditions shift, you can respond in hours instead of weeks. Where a competitor makes a move, you can analyze and react. And where an opportunity emerges, you can evaluate it immediately. This isn't just science fiction, this is happening right now. And at the organization using this platform, for example, the technology works, the economics work, the regulatory consideration work. And the question isn't whether this future is possible, the question is how quickly we get there as a profession. And I'll go to a call to action and closing. So what do I want to do with this information? First, try it. The open source code is available. You can deploy it in a test environment and explore the capabilities. See for yourself what is possible. And second, join to the community. connect with the other actuaries who are using this platform, share insights, contribute improvements, help to shape the future of this actuarial technology. This is collaborative work. We're building this together. And third, shape the future and provide feedback on what works and what doesn't. And request feature that matter for your specific domain. Define the use case that matters most for your organization. The future of actuarial analysis is collaborative. Humans and AI are working together, and models that handle the routine works, freeing actuaries to focus on judgment and strategy. Systems that democratize access to the sophisticated analysis across organizations of all sizes. Open source platform that belongs to the profession, not to the vendors. I believe deeply that actuarial expertise shouldn't be divided into haves and have nots based on organization size. I believe that mid-market insurers should have access to the same analytical capabilities as the Fortune 100 career. And I believe actuaries should spend their time thinking, not executing. I believe that this platform, imperfect as it is, evolving as it is, continues to be, represents a path toward that future. And technology exists, the economics work, the case studies prove it, and the question is whether you'll be part of building it. I'm going to publish everything on my GitHub, the code, the models, the documentation, the implementation guides, all of it open source, available to anyone who wants to use or improve it. And this is my email, and I'm really thank you to hear from you that maybe I want to know what you're building. I want to learn from your implementation. I want to collaborate on making this better, because this future we're building, it's not mine, it's ours. It's the future of our profession. Thank you.